right, so this is section 4-3. We are modeling with quadratic functions. A lot of things like gravity are and objects flying are modeled with parabola. So it is really beneficial to the physical sciences to model real data with quadratic functions. So the first thing I want to do is look at how do you put together a parabola equation when you just have points on your parabola. So what I want to do is write the generic I'll write it in vertex form. A times x minus h squared plus k, where h and k are the vertex, and a is the coefficient out front. So we have three. If we look at this equation, if we're trying to put together an equation, and I have x and y, I will have an a, an h, and a k. That totals 3 unknowns. And if I have 3 coordinates, then I have 3 equations, 3 unknowns, and we did a whole section on how to solve those. So I'm just going to plug in x and y 3 different times into my vertex for equation. Once I get it out, I will solve those 3 equations and find a, h, and k. So for 0, 0, I'm going to put in 0 for y, 0 for x, for my first equation. The second one, I'm going to put in 1 for x and negative 2 for y. Minus h squared plus k. And then for this one, I'm going to put in negative 4 for y and negative 1 for the x. So I have 3 equations and 3 unknowns, which thank goodness we did that section last chapter on how to solve using 3 equations and 3 unknowns. All right, so we want to simplify these guys out so that we can find important information. So for my first equation where I plugged in 0, 0, I'm going to get 0 equals a times h squared plus k. And then for this one, I get negative 2 equals a times 1 minus, there's really no easy way to say this one, plus k. I could FOIL out the 1 minus h, but I'm not sure that's going to give me any easier an equation. All right, so I am going to end up multiplying these guys out. So if I have 1 minus h squared, that is 1 minus h times 1 minus h. Please, if you put down that 1 minus h squared is 1 minus h, the value of h, variable squared, I will cry and lose a little bit of my will to live. You have to factor these guys out. So 1 times 1 is 1. 1 times negative h is negative h. negative h times 1 is negative h, and negative h times negative h is positive h squared. So essentially this is 1 minus 2h plus h squared. So it is not the same as 1 minus h squared or the same as 1 plus h squared. There is a middle term. If we look, negative 1 minus h squared follows something similar. Negative 1 times negative 1 is 1. Negative 1 times negative h is positive h. Negative h times negative 1 is positive h. And negative h times negative h is positive h squared. So this is 1 plus 2h plus h squared. So then these two over here are negative 2 equals a times 1 minus 2h plus h squared plus k. And then this guy is negative 4 equals a times 1 plus 2h plus h squared plus k. I am going to take my top term, my 0 equals ah squared plus k, and solve it for k. All right, so if you take the top equation and you go, I'm going to subtract ah squared from both sides, you get q equals negative ah squared. So where that k happens here and here, I'm going to do something called substitution. And just like having a substitute teacher, you take it out and replace it with something that should be equivalent. So we got negative 2 equals a. I'm going to distribute out this a. A times 1 is 1. A times negative 2h is negative 2ah. A times h squared is ah squared. And then I'm going to add my k value, which is negative ah squared. All right, now I'm going to do the same thing here. I'm going to distribute my a. Negative 4 equals a times 1 is a. 2h times a is 2ah. H squared times a is ah squared. Then I'm going to add my k to the end. Each one of these guys I'm going to simplify. So this one simplifies to negative 2 equals. I don't have any other a's for my a to combine with. Negative 2ah doesn't have another ah to combine with. And then ah squared plus negative ah squared is 0. Now I'm going to simplify the second one. Negative 4 equals. A doesn't have any a to combine with. Plus 2ah. Ah doesn't have anybody else to combine with. And ah squared plus negative ah squared is 0. So essentially I have two equations, and I don't know a or h. So I'm going to rewrite this guy with my a factored out. No, never mind. How about we use elimination? If I just add the two equations together. You can use elimination, right? If I add the two equations together, what will we get? You get negative 6 equals 2a. So if I just added these two equations together, the negative 2ah cancels, and I get a is equal to negative 3. If I have a is equal to negative 3, I could bring it up here. And solve for h. Negative 2 equals negative 3. Negative and negative is a plus. 2 times 3 is 6. H is h. I add 3 to both sides. I get h is equal to 1/6. Then we head up here to find k. If k is equal to negative a times h squared, negative and negative give you a positive. 1/6 squared is 1 over 36. 3 over 36 is 1/12. So now we have all the pieces we can put our equation together. So we got y equals a times x minus h squared plus k. All right, so let's look at a modeling problem. So here's a physics problem. Campers at an aerospace camp launch rockets on the last day of camp. The path of rocket 1 is modeled by this equation. Thank goodness we already have an equation. We don't have to find it. Check. Where t is the time in seconds and h is the distance from the ground. The path of rocket 2 is modeled by the graph at the right. Which rocket flew higher? So we either have this rocket here is rocket 2, or we have rocket 1 with this equation. So if we want to see which rocket flew higher, you can see that this max happened at about like 575. Very top, it's about 575 feet tall. And I just need to find the max of this function and compare the two. When you have a frowny face parabola, so it's facing down, at the vertex is your maximum. So if you can find the vertex of this function, you will know the maximum. We can compare it to our graph. So the vertex is hk, where h is negative b over 2a, and k is my function when we plug in negative b over 2a. So all I have to do is determine what is a and what is b. A is the guy in front of the square term, so he is negative 16 in this problem. Give myself some more room. So A is negative 16 and B is 150. So I'm looking for that vertex for this, our first rocket. So negative B over 2 times A. That is an easy calculator. Chug. 150 negative divided by 2 divided by 16 negative equals 4.6875. But let's get that as a fraction, because 4.6875, that's no fun. Okay, so it's 4 11/16, or 75 sixteenths. That's right. I did it on my calculator. If you don't know how to do that on your calculator, make sure you ask me. It's a valuable calculator tool to be able to do. Okay, so my x coordinate for my top is at 75 sixteenths, but I need truly, I want the height, that's the time. And I want the height. So I'm going to plug in 75/16 into my function. $150 times time plus 1 to find out what that k value is. It's negative 351.6. And then this guy is 703.1. And we're going to plus more onto that. So we plus 1 equals minus 351.6. And it equals 352.5. How does that compare to 575? Higher or lower? 352.5 higher than or lower than 575? It's lower. So which rocket flew higher? That would be rocket 2 went higher. Which rocket stayed in the air longer? Ooh, that's a good question. So we see that this rocket didn't land on the ground until 12 seconds. So our rocket 2 stayed in the air for 12 seconds before it crashed and burned onto the ground. I mean, landed in soft feather pillows and was just fine. So if we want to know how long this guy stayed in the air, so let's go ahead and graph it. All right, so when we graph our function, we see that this guy stays all the way in the air until 9.382 seconds. So which is bigger, 9.382 or 12? So rocket 2 stayed in the air longer. Was in the air longer. Okay, last one. What is a reasonable domain and range for each quadratic model? So we are going to go rocket 1, his domain for, we're going to say T. So for rocket 1, which is our equation, his reasonable domain is all T values in between 0 and 9.382. And his range is all H values from 0 to 2, oh no, it's the 352.5. And then rocket 2 is our picture. So we look at rocket 2. For rocket 2, he's a winner of everything. Must be hard to be such a winner. So the domain for rocket 2 is all the T values from 0 to 12. And his range is all the H values between 0 and, he goes up to 575. Using quadratic regression, that is a, you guys, this is a tool, a graphing utility. So if you have a graphing calculator, quadratic regression is something we do. It's the same as linear regression, except it models quadratic functions. So you'll be expected to use a quadratic regression calculator. You can go online and do that. That's what I'm going to show you. Or if you want to use a graphing calculator, we go step by step on how to do that. So this table shows a meteorologist's predicted temperatures for an October day in Sacramento. You put the time in your first list and your temperature in the second list. This is using a calculator. To use quadratic regression on your calculator, you can find quadratic regression underneath the stat button. Stat button is kind of near your alpha and your second button. And arrow over to calculate, and you can arrow down to quad reg. What I usually do is I will go do a search for quadratic regression online calculator. So this is the had to know quadratic regression calculator. So in this situation, we would put in our data in the X and Y. Come on. So 8, you guys can play along at home. 2, 4, but we don't put, after 12, we don't put 2. We put the number of hours after midnight it is, so we go all military time. So you look, I don't put 2 p.m., but I put, oh, it's 1400 hours. At 4, I don't put 4, I put whatever 12 plus 4 is, that's 16. And then at 6, I put 12 plus 6, which is 18. So you have to be really careful when you're dealing with time that you're inputting numbers that will actually give you out something reasonable. 81 and 76. Once you get all your data in, you put you just press calculate, and you get negative 0.4688x squared plus 14.7161x minus 36.124, which is the same as I got here. Alright, so we're going to take a moment, and you guys are going to do that very same thing. So you're either going to use a graphing calculator, or you're going to use an online computing device, and you're going to calculate the quadratic regression equation for this Denver temperature. So when we plug this into our graphing utility, we get, well, my calculator says y equals ax squared plus bx plus c, and it tells me what a is, what b is, and what c is, and we have to take those pieces of information and create our function. So y equals negative 0.329x squared plus 9.797x plus 15.571. Okay, so let's answer the questions on those. Here's the quadratic model. Predict the high temperature for the day. So I'm going to go ahead and graph this and find the max. So let me show you how to do that on Desmos. So you put this in negative 0.329 x squared plus 9.797x plus 15.571. And we are going to take a look and find the maximum value, which is at 14.889. So that is at almost 3 o'clock. It'll be 88.5 degrees. So we go back to here. So predict the high temperature for the day. So we have a max at 14.89, 88.5. So the high temperature is going to be about 88.5 degrees Fahrenheit. And then it's going to, the time is going to be 14.89 minus 12. So 2.89. But we usually don't refer to time as I'm at 2.89 o'clock. So we have to convert the 0.89 into minutes. How many minutes are in an hour? There are 60 minutes in an hour. And if I times that by 0.89, that's 53. So it's 253.